welcome to my session, and thanks for sticking around in this last session. So my name is Sergi Almar, and today I'm going to show you how to use real-time to make your applications alive. Right? So we're going to see a little bit about service-side events, how to use WebSockets with Spring, right? So you can use real-time or develop real-time applications with Spring. So how many applications do you use every day, right, which have real-time notifications? I guess there are a lot, right? So beginning from your email to, well, any other social network, Stack Overflow. Right? So when you go to Stack Overflow, that site kind of feels alive, right? So you get notifications, post a question, right? So you get the answer right away, right? So you get points right away, right? So it's kind of engaging, right? So it basically makes you stay there, right? So it's kind of feeling alive. So take a look at the history, right? HTTP 1.1, which is what we use today, right, has like 16 years already, right? So it's quite old. It's like, it was basically meant to be for this request reply kind of pattern, right? So it was not built to basically the use cases that we have today, right? So in today's applications, we need like real time. We need to push notifications, right? So the use cases are quite different from like 16 years ago. So back in 2005, we started with Ajax, right? At this point, right, I think that this is a key point in time because we started to try to find ways to have this real-time communication or bidirectional communication somehow, right, in different techniques, which could be kind of hacky, right? But it kind of worked right on top of what we had, which was HTTP 1. So back in 2011, we had the WebSocket Protocol, an API drafted, right? So at this point is where we could start thinking about real bidirectional communication, right, from the client side to the server side. And we have now, right, HTTP 2, which doesn't bring what WebSocket has, right, but at least we can have this flow from the server side to the client side, right? So not the same thing as WebSockets, which is truly bidirectional communication, right? But, well, it's one step forward. So basically replaces the old model that we had, right, in HTTP 1.1, which is quite old. So the hacky ways that we had to enable this real-time communication, right, was one of the ways was polling, right? So using the REST endpoints, we constantly asked those REST endpoints whether they had new information. So we constantly were doing requests, getting response, request, response, until we got something new. But that basically does a lot of requests, and maybe we don't get anything, and the client side needs to be constantly polling, right? And in order to try to get like new information from the server side. So that should be, that's basically how it looks like in JavaScript, where we set an interval and we basically start polling over and over again, right? So you can define the frequency of polling, but if you poll like every half a second or a second, that translates into a lot of requests, which shouldn't be done because maybe there's nothing, right, on the server side. So we found another solution, which was long polling, right? So in this approach, we basically started a request, and we left that request open until the server side had something to tell us, right? So when there was an event from the server side, we got the response. And at that point, we started another request. So the server side basically sent us whenever it had something to tell us. But, I mean, it's the same thing, right? So we still use HTTP, right? So we have to start the request, leave that request open, right? Not bidirectional at all. And then we had HTTP streaming, right? Which is basically leaving this HTTP request. And the server side will send some kind of partial responses, right? So it can leave the connection open and basically send, right, events, right, on that same connection. So that was basically another hacky way, right, that we had, right, to kind of simulate this request, this bidirectional communication. Not talking about Flash, not talking about iframes, right? So there are actually more techniques than these three that we see here, right? But these are some of the techniques that, using the current model, HTTP 1, right, we used, right, in order to simulate this bidirectional communication. So server-side events. Server-side events is nothing more than one form of this HTTP streaming, the last form that we have seen, right? So server-sent events is nothing more than having a standard way to do this HTTP streaming. But as we have seen, this is a unidirectional communication. So it's basically the server that is pushing, right, to the client. As the name says, it's server-sent event. The server sends events to the client side. The good thing is that it's built on top of HTTP. So basically, we're using the same protocol that we have been using, right, for a long time. So basically, we start this long-living connection, we'll leave it open, and the server side will basically send us events to the client side. So HTML5 introduced what's called the EventSource API to use server-sent events, right? And basically, that's a JavaScript API, which, well, we're going to see that in a second. But that will be like the workflow that we're going to have, where we start a request, we have a page loaded, and at this particular point, we create, right, an event source. Right? So this will basically be this long-living connection that the server will use to stream events to the client side. We're going to leave that connection open so the client side, at the server side, can send us events. But again, it's one-way communication. So we see here that the stream is sending to the client just one way, right? No bidirectional at all. Right? So just one way. But still, we can get these push notifications from the server side. So here's how the EventSource API looks like. Right? So that's JavaScript API, part of the HTML5. And we see here how we create a new event source. At the end of the day, that's going to point to an endpoint, right? An HTTP endpoint. And we can add event listeners to that event source. Right? So we can filter the type of events that we want to receive. You can actually receive all the events, or we can filter them out, right? Like in here where we add an event listener for something called memory, we add an event listener for something called uptime, right? So it's up to you what you want to receive, right, on the client side. It happens that Spring 4.2, right, the new release, current release, has support for server-sent events. So now, from your controllers, you can start like pushing notifications to the client side. So that's done basically using this server-sent event emitter. Right? So this will basically have a reference to this long-living connection. So you can use this server-sent emitter to send events to that particular client. Right? So basically how it works is that in your controller, you return this server-sent event, right, which you can then use to stream events back to the user. So I'll try to do some live coding here, right? So we're going to take an existing, not an existing application, but basically this application, which I called Spring Questions, right? So it has this UI. It's going to be the next Stack Overflow for Spring, but we're going to start from somewhere, right? So that's a kind of a static page where I have a button to create a new question, right? And I just type a new question here, right? How does this work, right? And for now, that doesn't do anything, right? So it's not doing anything. So we're going to use this and server-sent events and WebSockets, right, to bring this application alive. Great. So first thing that we're going to do is to basically start with the EventSource API. We're going to start creating this event source. So here I have my, my page. Right, that page, we only have one HTML page. And I'm going to start with an event source. Right? So I'm going to create a new event source, and I'm going to define the endpoint, which will be like questions, for instance. So now we have seen that we could define event listeners for that particular event source. And I'm going to define a listener which takes events of type Spring, right? So I want to receive questions which are Spring questions. I'm going to define a callback, so whenever I receive an event, I can react on that event. So I define here an event, and what I want to do is when I receive this event, I want to post or to put the question right on the website. So I have here the code for that, so I don't have to write it. So I'm just going to put it here, and that's what's going to be done right when an event of type Spring comes in. So now we have Now we have the client side, so JavaScript. So a lot of typos for sure, right? So no one gets it right the first time with JavaScript. So now we have the client side. Let's go on the server side, where we're going to use Spring for that. So we have here a endpoint, which is this new question. That's what's used when we create a new question. So that's basically what we're going to use to send the question to the server side. But now let's define the endpoint for the server as for the event source. So I'm going to define an endpoint for that. So here it is. Right? So I have this endpoint called questions, where I defined this server sent emitter, and I'm going to store this server sent emitter, right? Because I want to use that server sent emitter to push notifications back to the user. Right? So whenever a question comes in, which is basically what we do down here. Can you see that from the back? Yeah. Right, so I'm going to go through all my server sent emitters, and I'm going to send the question. Right? Let's do the imports. Here's a typo, like always. And I'm going to send, and we see here that we can pass a builder. Right? So we can build an event of a particular type. So we have actually in the client side that a listener for the events of type Spring. So I'm going to use the builder to build an event with the name Spring, and the data that this event will contain is the question that has been posted. All right, great. So now, let me fix that. Let's surround that with try-catch blocks, because the container sometimes doesn't understand, right, whether a server sent emitter is valid or not. Actually, on the client side, there's no notification, or the server side doesn't know whether a client is gone or not. So we only know whether a client has disconnected if we send some data to that client, right? And the pipe is broken, right? So that's basically the only way that we have to see whether a client is gone or not. All right, so I have my emitter in here, right? So that's basically the endpoint that the client will consume. I'm storing that emitter, so when a new question comes in, I'm going to basically broadcast all this stuff to all the emitters. Another thing that you can do is to basically define server sent emitter. Define a callback when the emitter is completed. So when the async request is completed, so when we detected that the client is gone by sending some data which will be sent to a broken pipe, then this callback will be executed. So what we can do is that if there's any error or whether the async request has been completed, I'm going to remove the emitter from my list. So I'm not broadcasting to clients which are gone already. All right, so that should be it. Right, so that should be everything. So now we should be able to go to Spring questions and send the question again. So how does this work? And here we see the question has showed up in here. So we start another browser. Let's put it here, localhost and I sent an event here. So second question, right? So we see that the question is broadcast to all the clients, right? In here and in here. So how does this work? Actually, if we take the developer tools and we do some debugging, sorry, let me rephrase that again. So we see here that there's this questions request, and that's basically the event stream. So here we're going to see all the events that come in. So if I post another question here, and I submit that, we see that there was an event coming in of type string, or Spring. Right? So we are filtering out the events. We are reacting only on the Spring events. Right? So that's basically what we're going to get. That could be a JSON. That could be anything. Right? So we're just sending like a plain strings. But if you want to send like a more complex structure, you can use JSON and parse that JSON and so on, which is usually what we do.
Is there any connection limitation?
Say it again.
Connection limitation, like on the browser.
So at the end of the day, it's HTTP. So the limitation, right, is HTTP. That's it, right? So if your browser limits your connections to 6 to the same server, that's the same limitation that we're going to have. Well, the question was, is there any limitations of the number of clients that we have, right? So at the end of the day, we are just building on top of HTTP, right? So it's a form of HTTP streaming. All right, so that was it, right? So from this screen, we were sending or consuming the REST endpoint, right? So posting the question, and we're broadcasting this question. So now, let's continue. That was a little bit about server-sent events, right? So it's actually one-way communication, right? The streaming from the server side to the client side, right? But the client side cannot interact in that communication. So that's why we're using REST, right? Or actually this post request, normal HTTP request to send the question. So now let's go to WebSockets. So how many of you used WebSockets before? How many of you used the Spring WebSockets before? Most of you, right? Great. So what are WebSockets? Right? So the WebSocket Protocol defines a way to have this real-time communication, right? Bidirectional communication from the client side to the server side and the server side to the client side. So the standard protocol, right? So we have the protocol and the API, right? Two different things. And the good thing about the WebSockets is that we are going to use the same ports as HTTP, port 80, port 443. But HTTP is not what we're going to use. We're going to use HTTP just in one or for one request, which is the initial one, right? The handshake. Whenever you want to use WebSockets, you have to negotiate, right? So first of all, you have to do a GET request, and this request will come with an upgrade header, which will tell us whether we can upgrade to WebSockets or not. Actually, the response will tell that. So that's the only place where we use HTTP for the handshake, right? After that, we are basically upgrading to WebSockets, and that's a TCP connection. So we don't have the HTTP protocol anymore. We'll be in a TCP connection, raw connection with no protocol at all, just bytes to be sent up and down. That's it. The good thing about WebSockets, though, is that it has a really small overhead. In the polling example, right, we were constantly doing like HTTP requests. So that has a lot of overhead because we need to send all these HTTP headers all the time. In a WebSocket, we only have like a frame, right, at the very beginning and a frame at the very end, right, of the message. So like more lightweight than any other request. So when should we use WebSockets? So every time that you want to do some kind of real-time notifications, right? So of course, gaming, right, is a a really big market for WebSockets, but that's not the only place. There are a lot of collaborative apps where when you go to Google Docs, right, when you share a document with other people, right, so this is real-time communication where you see what the other guys are doing, right, so that's another use case. Financial markets as well, where you have to stream, right, all these stock quotes in real time. Social feeds, right, when you go to Twitter, right, you want to get all these feeds, right, or any other social networks, chats, right, and many more. And actually, there's a trend now where actually I'm seeing like a lot of WebSocket-based APIs. So you are not consuming your WebSocket API, but you let someone else, third parties, to consume that WebSocket API. So you're going to see that quite a lot in the Bitcoin exchange, right? So a lot of big Bitcoin companies are like exposing its API, right, through WebSocket, so you can get real-time notifications, right, on the changes of prices and so on. Right? So Coinbase is another one, Bitstamp, OKCoin. So there are plenty of them which provide a WebSocket API. Right? So Daxboard, these guys, which basically give you the stream of all the gaming events, right? So they expose an API so you can consume all the gaming events that happen inside those games, right? So not only for gaming, right, but a lot of use cases, right, for WebSockets. Every time that you want to use this or do this real-time communication, bidirectional communication, it's a good place for WebSockets. So is anyone interested in WebSocket? So doing a Google search on Google Trends and just typing WebSocket, we see here a clear trend, right, where like we are using, or interested at least, right, in WebSockets more and more. So we see that we started back in 2009, right, where we started talking about, right, this real-time communication. And today, right, the trend is growing and growing, right, going up. Right, so certainly, right, it's something that you need to consider, right, so going real-time. Right, so that's actually the only way we have nowadays to go real-time. So we take a look at the WebSocket API. It's quite straightforward, right? So we're talking about the JavaScript API here, right? Part of HTML5 as well. So notice how we start something called a WebSocket, but we are not using HTTP as the schema, but WS. Right? So that's basically starting a WebSocket on a particular endpoint, right? In our case, localhost /WS. So at this point, we're going to do this handshake, right, with the server side. And the server side will tell us whether we can upgrade to WebSocket or not. At this point, we're going to have this long-living connection, right, with the server side, but we're not going to be in HTTP anymore. We're going to fall to, or actually to upgrade to a WebSocket, and we're going to be in TCP. So we see here that we have a different callbacks that we can define: on open when the connection is established, on message when we receive a message from the server side, on close when the connection is closed. Right? One thing about the server-side events is that the server-side event, if the server, or if it gets disconnected, if the server goes down, it will reconnect itself. Right? So it basically tries to reconnect over and over again until it gets another connection. But that doesn't happen with WebSocket. Right? So connection is gone, and you have to reconnect. Right? So we don't have that implemented. We see here that in the on open, we have this send method, which you can use to send messages to the server side. Great. So as we don't have any protocol, because we basically use TCP, we're going to be in, well, just sending bytes up and down, but we don't have like those headers, the payload that we had in HTTP. But during the handshake, right, during this initial request, this initial HTTP request, we can define a subprotocol, right? And at the end of the day, we need that. Either you build it yourself in your application, so your application needs to understand about the messages that we are sending, so you cannot build a protocol on top of that, or we use an existing protocol, right? So there are a lot of protocols that you can use, like STOMP, WAMP, MQTT, XMPP over WebSockets. Right, so we see here, right, an example of a stack where we're going to be in TCP, we're going to use a WebSocket connection, right, and on top of that, we use a specific protocol. Right? It happens that Spring WebSocket supports the STOMP protocol, right, which is a really simple protocol, right, really focused on this kind of messaging style where you have destinations, you can subscribe to those destinations, and you can send to those destinations, right? So really similar to like JMS, right, or AMQP, these kind of messaging protocols, but really simple and running on top of the WebSocket connection. So WebSockets are not only for browsers, right? So we have the JavaScript API, right? So we can use a browser and start a WebSocket quite easily, but you can also use WebSockets for your mobile clients. Right? You can have an Android application which starts a WebSocket connection as well. Or you can do server-to-server communication. That's also possible with WebSockets. Right? And actually, Spring has support for, or has clients for SockJS and STOMP, Java clients. So you can do this server-to-server communication as well. So WebSockets is not only for browsers, but you can have any other client, right, using WebSockets. All right. So let's see how to use a Spring to enable this bidirectional communication. Yes, Spring WebSocket. Right? So that's the good thing. So that's the weapon that you want to use, right, if you want to go for Spring WebSocket. So is anyone interested? Is anyone using WebSockets and Spring together? So we see here like more or less the same trend that we saw before with the plain WebSockets. Right? So just shifted a little bit because Spring WebSockets was part of Spring 4, and that came out like late 2013. So that's where we see the trend going up. But for sure, right, there are a lot of people interested in or using, right, Spring WebSockets. So here's the configuration. We're going to start with a plain WebSocket, right? So that means with no subprotocol, nothing. Actually, the Spring WebSocket support basically builds on top of the GSR because we have a GSR. We have a WebSocket API for Java, which is the GSR 356. So Spring WebSocket builds on top of this GSR, right? And well, first we're going to see how to use WebSockets without any protocol. And this is showing you the configuration. Java config, how many of you use Java config here? All raise your hand. No XML anymore, right? So we see that we have a new annotation called enable WebSockets, and you can configure WebSockets by extending the WebSocket configurer. So this WebSocket configurer lets you define the endpoint, right? So this is the endpoint that we used in here, right? So whenever we started this WebSocket, we need to define this endpoint somewhere. So that's going to be the endpoint that we defined in here, right? So we define an endpoint to /echo, and we define a handler for all the messages going to that endpoint, which is the one that we have down there, right? So let's do that. Right, so let's take the example that we had, and let's transform what we had, which is this one here, right, to WebSocket. So instead of using server-sent events, we're going to use WebSocket for the communication. So let's go back here. Let me stop that because that's going to bother me. And I'm going to start with the configuration that we have seen. So I'm going to define the WebSocket config. I'm going to define this is a configuration. And I want to enable WebSocket. Okay? So now I have to kind of customize that. So if I take a look at the documentation, it tells me that I can customize that by implementing this WebSocket configurer. So I'm going to implement this WebSocket configurer and see what I can do with that. So first thing is to define the endpoint. So let's define the endpoint, right? Because we are going to connect to this endpoint. We're going to define that we have an endpoint, this registry.addHandler. We're going to define a handler in a second. And the path will be, let's say, /questions, right? And the handler will be, right, a class which will handle all the messages. I have here a convenient class that I just created. And notice how I'm extending from something called text WebSocket handler. On a WebSocket, we can send either text messages, or we can also send binary messages. Right? So in Spring, if you want to define a handler, you can either define a text WebSocket handler or a binary WebSocket handler. Right? So we'll be dealing with text now. So that's why I define this text WebSocket handler. So I'm going to pass that to the registry. Right, so the registry is aware that every single WebSocket connection to /questions are going to be handled by the question handler. And what the question handler will do, right, it has these two hooks. We have a hook which we're going to implement called after connection established. So I'm going to keep the WebSocket session so I can broadcast to all the WebSocket sessions, really similar to what we've done with service and events. So I'm going to create temporarily a list of WebSocket sessions. I'm going to store all the sessions to the collection. So now, whenever I receive a message will be, in our case, a question, because we're going to refactor our application, and instead of posting to that endpoint, we're going to use the WebSocket connection to send the question. So whenever we receive the question, which is a text message, what I want to do is to broadcast that question to all the other connected users. So here we're going to go over all the sessions we have. And we're going to send a message, which will be the message that we receive. Right? And I want to have control over the exceptions. I'm going to the try-catch block here. All right. So now we have the server side. We have a handler. Whenever we get a question, I'm going to broadcast this question to everyone. So let's go and refactor the client side. So the client side was commonly implemented by using service and events. Right? So now we're going to get rid of that. Sorry. Let's just remove that so we don't have it here. So I'm going to start a new WebSocket connection. So I have a variable here called WS. So I'm going to create a new WebSocket connection. WebSocket, socket. And I need to define the endpoint. And remember that we're using WS for that. I'm going to the localhost 8080, and that's going to be the endpoint was called questions, if I'm not mistaken. Let's check that again. So that was the endpoint. Right, so we need to connect to that particular endpoint. So now I can define the callbacks. What should we do when we get a message? So ws.onMessage. And we can define a callback here. And whenever we get a message, we want to put it in the list of questions. So basically, the same thing that we did before. Here. All right. So that's called data. And yeah, let's leave it like this. And what I need to refactor as well is basically how we send the question. Right? So if we recall, whenever we send a question here, so this question was basically sent using a post request. So now instead of a post request, I want to use the WebSocket session to send that particular message. So I'm going to replace that. So I don't want that anymore. So what I'm going to do is to use the WebSocket session to send something. And this something will be what's in that text area. Right? So I'm going to use jQuery to get what's in that text area. We'll take a look at this text area. Let's see how it's called. That's called question text. Right? So I'm going to go down here, and I'm going to define that I want to get the value of what's in the question text area. All right. Great. So let's see if that works. Right, so I'm going to restart my application. I'm going to restart that, and let me get Chrome better. I'm going to check the developer tools, and let's see what happens here. I don't see anything. Let's check back that we did the right thing. There's no errors, or there is an error. So it's something that's always JavaScript. Always. So where's it? Oh, we're going to get there. We're going to get there. So there's something. Where is it? That's it. Where is it now? It's always the same. If you see it, help me out, because I'm not saying it. WebSocket looks all right to me. So if not, I have something to cheat, right? So I have always that ready, I think. Here it is. Right, so let's do that so we don't lose time here. And let's replace that with WebSocket for now. WS, and we had this question here. All right, so let's try that. I don't know where we get this. Yeah, but that's not the problem here. It's always JavaScript. It's not type-safe language. So I don't know what we have here. Oh, here you go. We had this guy here. Let's see if that helps us out. Yeah, it was that. So let's put that in here. All right. I'm really sorry about that. Let's copy the whole thing then. Let's just start deleting again. Sorry about that. Okay. And this was questions. Any questions so far? So let's see if that we can make it work. To append, that's actually on the server side. So we are not storing anything on the server side. We're basically like pushing all the questions, but we're not storing anything on the server side. So in this example, we are going to basically get what the new things, right? So not the old things, but you could do it.
That's what I mean in email. In the previous example, we had you remove the connection from a list from that email.
Yeah.
We're going to do that with WebSocket.
Yeah. So, sorry. In WebSockets, the disconnects are detected automatically, right? So you don't have to do anything. Okay. That's really embarrassing, to be honest, because that should work right away. Questions? Let me see the endpoint again. WS is actually up here, right? So we should get there. In 8080, and really not sure why we get this exception. That's really embarrassing, though. There should be some close bracket something here, which I don't see right now. This one here? Yeah, that's nested here. So localhost 8080. Well, let's continue. We're going to get there for sure. All right, so basically what we're doing here is we're having this controller. We're not doing this controller, but we're having this configuration here with this handler. And in this handler, we don't have any protocol. We're basically sending messages with the WebSocket connection, but we have to parse those messages. We have to build some kind of a protocol on top of that, which it's quite hard, right? Because it's really low level, right? And at the end of the day, you should build your own, either your own one or adopt an existing one. So what we are going to do is to basically use a STOMP, right, for that. So in Spring, we either go for the raw WebSocket built on top of the GSR, or we use STOMP, right, as a protocol. So STOMP is really a really simple protocol, which lets you subscribe to destinations, send messages to destinations, and subscribe to destinations. So it's really similar to JMS, AMQP. And we're going to find different types of destinations. We're going to find what's called application destinations, what's called broker destinations, and what's called the user destinations. All right, so as we're using a protocol, which is a STOMP, we need someone who understands the whole thing, who understands, right, what a STOMP is. And that's a broker. So at the end of the day, the broker will take care of the subscriptions, the broadcasting, the sending, right? And we're going to see two different types of broker, but if you send a message to a broker destination, which is identified by a prefix, that's going to go directly to the broker, and the broker will decide what to do with that message. If you send a message to an application destination, which again is identified by a prefix, we're going to delegate to one of our application components, which happen to be a controller. So in Spring MVC, we use those controllers with handler methods. So in Spring WebSockets, we're going to have more or less the same programming model. We're going to use same controllers with really similar programming model, but we just make available a similar programming model because underneath, right, it's completely different, an HTTP request from a WebSocket request. But we're going to turn into a message-driven, right, kind of architecture where the client side will send message to the destination, receive to the destination, subscribes, and so on. And then we have the user destinations. So user destinations are basically the ones targeted to a specific user, right? So in the previous examples, in the broker destinations, for instance, those broker destinations are more broadcast destinations where we're going to send the message to everyone which is connected. In the user destinations, you can target a specific user. So the client side will basically decide the destination, and depending on the prefix of that destination, we're going to send to the broker, send to the user, right? Send to the application itself. Right? So a broker could be either a simple broker. So Spring comes with a built-in broker, right, which supports a subset of the STOMP protocol, and it stores everything in memory. So that's not what you want for scaling. Right? So it's storing everything into memory. So if you scale, right, this is not going to share anything. Or you can use a broker relay. Right? So this broker relay is basically delegating the messages to a full-blown STOMP broker, which could be RabbitMQ, could be ActiveMQ, could be any other broker which supports STOMP, which is much better for scaling. Right? So at the end of the day, a STOMP broker can be scaled. Right? So all your instances of your application will be connected to that particular broker. All right, so let's try that again. Right? So what we're going to do now is to get rid of this configuration. Sorry. Yeah.
Like I noticed the error message in the console said that you guys are trying to respond to WebSocket because you have a question controller to slash questions.
Oh, that could be, yeah. That's it. Let's remove that controller here. Good point. So it's by using the same name. Let's try that again. Yeah, so WebSocket support WS or WSS, which is encrypted WebSocket. So you should always use encrypted WebSockets, right, for that. Network. So yeah, thank you very much. You went through, right? So in the previous example, that's what I wanted to show you. So the problem was that we had a REST endpoint with the same name as the WebSocket endpoint, right? So that's why it didn't go through. But yeah, here we have the questions request, which is down there. And notice that this is an HTTP request. It's a GET request. And yeah, we'll see that here. And we get a response, which is 101, right? Which means that we can switch protocols to WebSockets. So from now on, we're not going to use a WebSocket. We're going to use, HTTP, we're going to use TCP. So here we have the tab called Frames, where we're going to receive all the messages on that WebSocket. So in this tab, we're going to see all the messages that are going to be sent and received from the WebSocket. So we miss that chance, right? So we miss the demo from like plain WebSocket. So now we're going to go for the demo of STOMP over WebSocket. Right? The STOMP over WebSocket basically gives you a better like workflow, right? Where you can have a protocol right on top of WebSocket, and where you can map those messages directly into your controllers. So great. So now that it went through, right? Thanks for that. We're going to kind of refactor that. So here we had a simple WebSocket. So before going forward, what happens if a client doesn't support WebSocket? Right? So let's say that we're using an all Internet Explorer version, or we're having a proxy load balancer that doesn't accept WebSocket connections. Right? So in that case, our application wouldn't go through. I mean, we won't be able to use WebSocket, so that connection won't go through. So whenever you use WebSocket, right, the fallbacks are really important. Right? So we should have somehow a way to fall back to another protocol if WebSockets are not supported. Spring supports SockJS. And SockJS basically provides the fallbacks for us. So the initial request is going to try to see whether we can use WebSockets. If we cannot use WebSockets, then it's going to fall back to another protocol, like long polling or polling, right, or using an iframe. Right, so the way to tell the server side to use SockJS is quite straightforward. So simply using this, where are you? With SockJS, we're going to enable the fallbacks. Right? So we just say that this endpoint uses SockJS. So whenever we enable SockJS, we do a request again. Have I saved the index questions? Yeah, we're going to see an extra request here, which is the info request, and that's done by SockJS. So this is the HTTP request that SockJS will do to see whether we can use WebSocket or not. It happens that we can use WebSocket, right? So we're going to fall back to WebSocket, and we see here that SockJS has some heartbeats implemented, because if you open a WebSocket connection, that's going to be a long-living connection. So what happens if that long-living connection doesn't have any traffic at all? Because there are a lot of proxies that will close that connection. So that's why SockJS has these heartbeats implemented. So there's something going on that connection. So the connection is actually alive. So that's why you see this H here in the frames, right? So going up and down, right? Just because of that. All right, so now that we have SockJS here, we are going to define the STOMP client to be a STOMP over WebSocket. And the STOMP has more or less a really similar API. Sorry, SockJS had a really similar API. So now with the STOMP, what we're going to do is to use the STOMP protocol. So we'll be able to subscribe to destinations, send messages to destinations. So we're going to turn into more a message-driven architecture, right, from the client side to the server side. So I'm going to STOMP subscription. So I'm going to get this to simulate the subscriptions. All right, so here we see that we have a callback. So we connect to WebSocket, right, using SockJS. So notice that we are using SockJS for the fallbacks, and then STOMP over that connection. And here we see how we connect through the STOMP client. So that will connect to an endpoint, which we haven't defined yet. And we have a subscription to /topic/questions. So this is /topic/questions will be, we're going to see how to configure that, a broker destination. Right? So every time that we send a message to /topic/question, we're going to receive it because we have subscribed to that destination. And we are going to react on that. Right? So we're going to see that in a second. So let's configure the server side for /topic/questions. Well, not first. WebSocket, let's say broker config. So we're going to define a new configuration because we're using a broker now. Configuration. So now instead of enabling WebSocket, we're going to enable the WebSocket message broker because we need a broker for STOMP. We're using a STOMP. Who understands a STOMP? The broker. Right? So we need to configure WebSockets using the message broker. So we go to the documentation, we'll see that it's telling us to extend this class here. So I'm going to go and extend it to further configure the configuration. All right. So let's implement the abstract methods. So this configuration, again, lets us define the endpoints. So those endpoints are going to be STOMP endpoints. Right? So remember that we have connected to a particular endpoint. So we're going to define the endpoint here. So we're going to define the registry, and we're going to define a new endpoint, which was /questions. We're can also run on top of sock.js, so we can define that this endpoint runs on top of sock.js. Right? Great. So now it's time to configure the destinations, the type of destinations. So I'm going to configure the message broker, this one here. Remove this. I'm going to configure that I have some applications destinations. So remember that application destinations are the ones that are forward to your controllers. So I'm going to define that any app destination that starts with a /app will go to our controllers. I'm going to define the broker and the destinations that the broker can process, /topic and also /q. Right, so with this configuration, we are kind of done. Right, so we have added the endpoint /questions. We have configured the different prefixes for the application destinations and for the broker. And notice how we are using the simple broker. So this is the embedded broker. This is the one that stores everything in memory, right, that basically Spring provides to you. All right, so with this configuration, we're going to come back to the client side, and we see that this was the endpoint. We haven't configured any handler because we're going to use this broker destination. So whenever we send a message to this broker destination, we're going to go to the broker, and the broker will do the broadcasting of the message. All right, so I'm going to replace that, the form. I'm going to use now, the STOMP client to send the question. And I'm going to react on any question, right, by putting it into the list. Right, so that's going to be message dot body. Okay. Great. So let's start this app. Let's see what happens here. Great. So we had our WebSocket connection going on. This is a WebSocket connection. And let's look now at the messages from this connection. So see that there's some activity going on already. And we see messages on green. These are the messages sent by the client, right, we. And we see messages on white, which are the messages sent by the server side. So as we're using a STOMP, right, we're connecting using a STOMP, so that's basically this frame here, the connect frame. And we were subscribing to a destination. Right? So basically, that's another message that we're going to send to the server side so we can receive the questions, right, on that endpoint or that destination. All right, so now if I send a question, can we use WebSockets? Something wrong happened here. Destination. Yeah. Let's go back to the client because that send is incomplete, right? So actually we have to send to a destination. So whenever we want to send, I'm going to send to /topic, of course, questions, no headers, and that's going to be the body, right? So we missed the destination. It's not like a raw WebSocket where you don't send anywhere, you just send to the WebSocket connection. So we had to define where we wanted to send that message. So we go back to our client. Let's do that again. Can we use WebSocket? And here we see, right, how the question appears. Right, so we see what was sent. we see that we have a send command here, sending to the destination topics.question, and this is the payload. Can we use WebSocket? And so that was the message that we sent, and right after, we received a message. So we received a message on a /topic/question, and that was a subscription that we had. So that's why we are basically seeing that in the list. So if we open up another browser here, and can we use server-send events, that will basically show right on both pages right away. So here and here. And basically, that's because we are subscribed to that destination. So that was a broker destination. So notice that we haven't mapped anything in our controllers. So what if we want to process that message? We can actually use a controller for that. So let's use the controller we had, which is gone. So let's create a new one. Question controller. And let's map those messages. So now we're going to use a really similar programming model as in Spring MVC. I guess that you're familiar with request mapping for REST. So now instead of request mapping, what you can use is message mapping. And define what destinations you want to process. Let's say questions. So every time that we send to an application destination, we're going to forward or delegate to our controller. So notice that we just defined a /questions because the prefix was defined in the configuration. Sorry, this one here. So this configuration defines that everything that starts with a /app will be forwarded to the controller. So /app/questions will basically forward to our controller. So the payload will come, right? Or actually, if you define any class here as an argument, Spring will try to map the payload into that class. It could be a JSON. In our case, we're just sending a string. That's why we are defining a string here. And notice that the return type is a string as well. So we'll be returning the same question with, I don't know, to uppercase. All right? So the interesting thing here is that even if we process that message, we don't know what to do with the STOMP message. So the return of our controllers will be sent to the broker anyway. So it's up to the broker what needs to be done with that particular payload. So this string will be sent to the broker, and the broker will take care of the broadcasting of that message. So let's try that. That works. So now we're going to change where we send the question, and we're going to define that this is going to be sent to /app/questions. Notice that we are not changing the subscription. The subscription is still to /topics/questions, because by default, when you send something from the controller, the return will be sent to a destination with the prefix /topic and the same name of the destination. So /app/questions will be sent to /topic/questions. And so that's why we are still subscribing to /topic. So let's refresh that, and let's try to send a question. Right? Can we use our WebSocket? So we see here that the question came in uppercase because it went through our controller. The return of our controller was sent to the broker, and the broker did the broadcasting. All right? So these methods are quite flexible. I mean, the signature of these methods are quite flexible, right? Like in a Spring MVC, we can pass the principal, we can pass headers, right? We can pass several things, right? So by default, what the WebSocket configuration is going to do is this is going to pass the principal from the HTTP request, right, into the WebSocket session. Because we have seen that there's only one place where we use HTTP, the handshake. At that particular point, we're going to take the principal from the HTTP session and just pass it to the WebSocket session, which is completely different because we're not going to get access to HTTP anymore. So that's why we're going to copy that into the WebSocket session. So we're not having any principal here. So the configuration lets us define what's called a handshake handler. Right? So this handshake handler lets you interact with the handshake request to do multiple things. Right? So I have a handshake handler implementation. Not this one here. This one here. So this handler, stop that. Yeah. Principal, here you go. Great. So we have here a handler, which I just implemented, which will set a random username to the connected user. Right? So we can have a user, right, to deal with. Because so far, the users were anonymous, but we want to be able to identify those users because we want to send private messages to users or identify who is sending the question. So I'm implementing this handler, and I'm going to pass this as a handshake handler. So in the handshake request, the handshake will be passed to my handler before establishing the WebSocket connection. And this handler will assign an anonymous user to the connected user. So let's try that in a second. And we're going to see that during the handshake, or whenever we are connected, we're going to get assigned a random user. All right, so let's open the developer tools. Here you go. Great. So you can also use the console for that. Maybe you're going to see that better. Great. So we see here that in the connected event, we got the username, which basically is random, and we are called now old-fashioned gorilla. Right? So that's going to be our username. And we see that we retrieve this username when we connect to our endpoint. So now we can just go to our controller, which was this one here, and we can pass the principal, for instance. And we can add this principal to the question. So we can say this question was by, and the principal name. So we can identify the name, right, of the user that sent the question. So we go back to our WebSocket sample. We're going to send a message now. Can we use WebSocket? And we're going to see that the WebSocket was by Toxic Warrior, whatever. Right? So every time that we connect, we get a new username. But we're able to intercept that, right, and get the principal from our controller. That's nice. That's nice. Let's open another WebSocket connection here. And I know that this guy is called, let me open another tab here. Yeah. Localhost 8080. Yeah, we know that this guy is called Toxic Warrior, right? So I want to be able to send a message to this guy directly, right? A message to this guy, and I don't want everyone to see that message. So it happens that we have the broker destinations we have seen, right? So it doesn't go through all our application. We have the application destinations will go through our application and then to the broker. And we have the user destinations, which basically target a specific user. So now I want to target this specific user. So what we can do is to define another subscription. And this subscription, let's copy that, will be for just myself. All right, so user dot queue dot, let's call it private. All right, so and when I receive that, I want to, let's copy that, show the message right away. Great. All right, so I have another subscription on something called user queue private. Right, so everything, or all the destinations starting with user, are user-specific destinations. It's just for myself. Right? So how can we send a message to a user? So sending a message to a user, let's do it directly in the console. Right, I'm going to get this. Well, let's start a new WebSocket connection here. So it picks up the new changes. And I'm going to get the new name, which we got, which is toxic agent. Right? So that's basically the name of this connected user. And I want to send a message just to this connected user from the other connected user, which is called aggressive hedgehog. Right? Well, we see it here, down here. Right? So we're going to use the STOMP client to send a message to a user, and now I'm going to define the name, and that was a queue called private. Let's go this way. Private. That was the name of the destination. Those are the headers. I don't want to specify a header. And here's the message that I want to send. I'm going to send hi there. All right. So that's basically the client. So let's see what happens when I click here. Nothing happens. So great. That is not defined. Yeah. Let me just quickly change that. The message is called message, not data. Thanks, type safety. So now this guy changed his name. So it's called now Annoyed Flamingo. Yeah, let's call it like this then. So now I can go back to my other client. I can replace this user here. And let's see what happens. Hey, hi there. Right, so I saw it here. We can start another client. Just put it here, in between these two here. Right? And we're going to see that it only goes right through to the annoyed flamingo, right? So it doesn't go to this one here. Whereas if I send a question, a new question, right? So we see that the new question went through, or went to all the browsers, right? So by the aggressive hedgehog, right? So all of them received that particular message. All right. So now we have actually seen the simple broker, right? So that was in memory, right? So what happens if we scale, right? So everything will be in memory. We cannot scale with that. We can change that though, and we can forward that all the messages to a full-blown broker like RabbitMQ. So let's change that configuration, and instead of the simple broker, we're going to use the STOMP broker relay. So STOMP broker relay delegates to a RabbitMQ or whatever you have. So I actually have RabbitMQ here. Localhost 1. Yeah. Here you go. I have RabbitMQ, and yeah, let me see if we have that clear. Yeah, well. We're going to use we can actually configure this, this broker with host name, the port, right? The username, the password, right? So I'm going to use the defaults, but I'm going to change the virtual host of RabbitMQ, which is to GX15. So all the messages or all the queues will be created on that particular virtual host. All right. Message that connect. Let's say access denied because we are not granted here. Well, let's use the default one then. All right, so this will basically delegate to to RabbitMQ, right? So now RabbitMQ will process the subscriptions, will process the messages, will do the broadcasting for us, right? So internally, Spring is using Reactor TCP to connect to that broker, and for every single connected user, we're going to establish a connection to the broker, right? So all the destinations will be handled by RabbitMQ. So we have changed to STOMP broker. So if we go to our application here, we should be able to, well, maybe we're going to see it here. Yeah. So we see here that we are connected to RabbitMQ, so we're not connected to the simple broker anymore. If you connect to simple broker, the server says unknown, right? And if we try to send a message here, new question, you need to be connected as well. New question. And I submit that, well, we get the same message, right, on both screens. But that's not going through the simple broker in our application. That's going through RabbitMQ, right, more scalable. All right. Any questions so far? So the question is, it seems that the browser connected to your app and the broker, both of them, our client only connects to the application, right? So the application, our Spring application, is the one that connects to the broker. So there's no direct connection from the client to the broker. It's always going through the application. So the application will basically detect the type of message, and depending on the prefix, will delegate to your controllers, will delegate to the broker, will target a specific user, right? But there's no connection from the client to the broker directly. Okay. The application, yeah, that's right. So well, the question is, if I have multiple instances and there's a user connected to a specific node, does it reconnect if that fails to another node? WebSocket doesn't have reconnection implemented. Server-send events will try to reconnect to the same endpoint, but in here, right, there's no reconnection. Reconnection needs to be handled by you, so you'll have to reconnect, right, to another node. Okay. So the kind of destinations that we use are, well, non-persistent. So there's no buffering there. So it's basically delegating or actually forwarding the message to the subscribed users. So if you don't have subscription, you're not going to receive it. And if you connect again, you're not going to receive the messages that were sent before. Right? So those messages will be gone. Okay? If you want persistency, you have to implement it yourself. So if we take a look at RabbitMQ and you go to the overview, you have something called the socket descriptors, right? And here we have 138 available. So that means that I can only handle 138 connections, right? If I can go over that, I have to scale, right? So it all comes down to the server descriptors that you have in here. It's not about, right, how many connections can RabbitMQ handle, right? It's all about your operating system socket descriptors. Yeah, well, it happens that, the question is 138 web clients. It happens that every single client that connects will have a connection, its corresponding connection to Rabbit, right? So, all right, so for scaling, right? So what happens if I have more than one node, right? So if we have more than one node, let's say I have 2 nodes. What happens here? The thing is that if we have this scenario where we have a couple of nodes, and Bob and Alice are connected to the first node, and Joe is connected to the second node, if Bob wants to send a message to Alice, which is what we have done, right, in the example, right, it sends a message to users/Alice queue messages. It will go through, right, because that instance knows about Alice, knows about that connected user. It knows about that session. Right? So the user destination will be resolved, and eventually Alice will receive that message. But what happens if Alice now wants to send a message to Joe? That particular instance doesn't know about that WebSocket connection. Right? So that destination won't be able to be resolved. So that message will be lost. So Joe won't be able to get any message. But luckily, we have a property called user destination broadcast that we can configure at the broker level. So that's only if you use a STOMP broker relay, right? So delegating to Rabbit, for instance. So when a node cannot resolve a destination or use a destination, it will send a broadcast message to all the other nodes in order to let them resolve that destination. So eventually, one of those nodes will know that particular user and will know the session which is assigned to that user, so it can resolve the user destination. So now, if we enable that, Alice will be able to send a message to Joe, because even if the first instance is not able to send that message using RabbitMQ, that instance will broadcast to all the other instances, and all the other instances will have the chance to resolve that destination. And eventually, Joe will receive that message. Right? But even if the second instance can resolve the destination, if we have the same scenario and we ask this first node, how many connected users do we have? That's going to say 2, because we have 2. Right? And if we ask this second instance, how many connected users do we have, that will say 1. Right? But that's not like the whole picture, right? Because in our application, we have 3 connected users. Right? So internally, Spring keeps track of the users that we have connected by something called the simple user registry. The default strategy is to store everything into memory. That means that all the users and subscriptions will be stored in memory. But if you enable a property to broadcast the state of the user registry, we'll be using the multi-server user registry. And this guy will basically broadcast the state, right, of the user registry, so everyone knows, right, all the users that are connected. So all the nodes will have the full picture of all the connected users. Right. So now, there's going to be a synchronization. Right? There's going to be a destination used for the synchronization of the user registry. So all these nodes will propagate, will broadcast the users that are connected. So now, if we tell the first instance how many users, or ask them how many users there are, that's going to tell us 3. If we ask the second node, that's going to tell us 3 as well. Right? So basically, all of them will have the full picture because there's a synchronization of the user registry. No. This is new in Spring 4.2, right? And when this was done, there were 2 options. Either you back the user registry by Redis, or you synchronize that using a messaging system, right? So the Redis support is not there. That's the only way to do it right now.
But if you have Spring Session,
But you're not using the session here. There's no HTTP session. you have a WebSocket session, right? But that's not using the session, right? The simple registry is storing all the users in memory. So it's not using the session at all. Right? So even if you use Spring Session, that won't help, right? So internally, it can become really chatty, right, at some point, right? So that's the first initial support to support like multiple servers or nodes, right, with WebSockets, right? But all of them are broadcasting the internal state, right, and all the users, actually.
When you talk about broadcasting, are you talking about like subnet broadcasting?
No. Question is, when I'm talking about broadcasting, are we talking about subnet broadcasting? No. Whenever you configure that, using this user destination broadcast, you define a destination, right? /topic, / unresolved user destinations, for instance. That's going through Rabbit. So all the nodes are connected to Rabbit. So there's going to be a destination which is used just for this, right? So it's not about at the network level. Okay.
The multi-server registry, what happens when one of the nodes is either gracefully or ungracefully brought online?
Mm-hmm.
Is that any sort of resolution for now that node was then included sessions?
Mm-hmm.
Does that registry have any sort of cleanup process associated with it?
Well, so every single node broadcasts like every 10 seconds. So we notice that this is not there anymore, right? So the only support that we have now is just this, right? So broadcasting, right, the internal state, and basically based on these 10 seconds or 20 seconds, right, we know that someone is down. All right. Any other questions so far?
Do you have any endpoints or metrics for WebSocket?
Is there any endpoint for metrics on WebSockets? No, there are not. I just built some Spring Actuator endpoints for WebSockets. So about to send a PR, and it will basically tell you, or you'll be able to debug all the messages that go through the system, the endpoints, and the stats as well. Actually, well, it's not exposed here. There's a class which is called Message Broker Stats, which has all the stats from how many messages were processed, the number of connected messages, subscribed messages, and so on. So there's actually some stats that you can get, right, that you can expose through HTTP if you want. All right. Well, just one slide on security because we are running out of time. The GSR doesn't have any security implemented or defined. So as we are not using HTTP, if you use like normal endpoint protection, that won't help much using WebSockets. Well, it will help you at one point, which is at the handshake level. So at this point, that was an HTTP request. So first, what you have to do is to protect the endpoint, the handshake request, right? Second thing that you should do is to always use WSS, encrypted connection, right? And then you should apply authorization at the message level, right? Because Spring Security 4 has support for WebSocket security in the terms or at the level of messages. So that means that you can protect subscriptions, you can protect messages to specific destinations. So in this example, we see that we protect the subscriptions to /topic/admin notifications with the role admin. Second line, we are protecting the messages sent to /topic orders or a /topic order conf, and we're denying all of them. Right? So we are not letting you send any messages to /topic orders or a /topic conf. You can subscribe to them, but you won't be able to send messages to them. Right? And then the other message requires you to be authenticated. Right? So really similar to what we have in HTTP, but applied to messages and subscriptions. So you have a fine-grained way to protect your messages. Because maybe you want someone to read or to receive messages from a destination, but you don't want them to send messages to that destination, right? So with normal WebSockets, there's no way to do that, right? Because you only have HTTP. All right, so that's everything from my side. If you want to learn more, I recommend you to see this presentation here, which is the one I did last year, which is a deep dive, and it basically tells you a little bit about the workflow, and you'll basically understand the workflow on what happens when we send those messages. Another thing, if you happen to be in Europe, right, I organize a conference called the Spring I/O, and that's going to be May 19th and 20th. So I invite you to come over. That's going to be a good show. So all the Spring engineers, right, and all the Spring guys will be there. All right, so that's everything from my side. So I'll leave it open for questions now.